there's a lot of unknown involved in epigenetics. And I always joke around that in the old days when I was learning medicine, every time the teacher, or the physicians didn't know what caused a certain disease, they would say, virus. It's a virus, right? That was equivalent to saying we went through all of the other 10 possibilities. It's not any of those. It has to be a virus. Today, epigenetics is something like this. Every time you don't understand the phenomenon in nature that's connected with genetics, people say it must be epigenetic. And I can understand that, but a lot of the things that people attribute to epigenetics are probably not true. But I can tell you where the areas that probably are important. One is in cancer. Okay? We know that cancer cells, there are different ways of initiating cancer, of triggering cancer. But the cancer cell itself behaves the way it does because it's undergone epigenetic changes. In other words, mostly its text, its instruction booklet is mostly intact. But it's undergone changes of annotation that make it behave wrongly or badly. Right? And the understanding of that concept, okay, automatically now points a finger at saying the way to solve the problem of the cancer cell is to attack the epigenetic program. And we're seeing more and more of this now. We're seeing the appearance of drugs that are being used to change DNA methylation, drugs that change other aspects of the epigenetics of the cell. And so this is a very important direction. And one of the principled reasons, the fundamental reason why it's an important direction is because even though we've seen over the last decade or 15 years, we've seen amazing progress in attacking certain types of cancer, certain types of tumors. Really amazing work. All of those solutions are local solutions that have to do with one tumor type. And many times, one tumor type and only certain people. Okay. What's very promising in epigenetics is that every tumor in every person, in every tissue, undergoes almost the same epigenetic changes. So if there's a place to look for a target that's general and fundamental and perhaps defines the cancer problem, it's this. And so there's a lot of hope in that direction. Another thing that's very interesting that is really more shady, or that we really don't know, is that we know that people undergo during their lifetime, they undergo changes. And changes in the way cells behave. Sometimes it turns out this is a disease, sometimes it's a difference in behavior, but things happen to people as time goes on. And the changes that happen seem to be permanent. In other words, it seems like something can happen early on in your life, and then it affects you for the rest of your life. Not a transient change. Not that you drank something, it made you sick for 3 days and you recovered. Something that changes the person for long term. And there's a lot of good reason to think that those changes come about because of epigenetic changes. In other words, again, emphasis, the text is the same, we're still working under the same instruction booklet, but something from the environment or something from our life experience has managed to annotate the text differently. And And there are indications that this is the case, but not enough yet. But this is one of the directions that I see epigenetics going in the future.